Here we're being asked for the equation of a line tangent to f passing through this point, and where f has this weird limit property, which we'll deal with in a second. But whenever you're asked to find the equation of a tangent line, you need two things. You need a point, and you need a slope. Well, guess what? You're given the point. That's already there for us to use. So 3, 2 is our point. What about our slope? Well, our slope happens to be the very last thing we have. That's 4. Now, why is it that this whole stupid limit thing is the derivative, or is the slope? Well, first things first is this is what's called the limit definition of the derivative. Anytime you have limit as h approaches 0 of f of some number plus h minus f of that same number divided by h, all that just means f prime of, well, in this case, f prime of 2, because that's the number being plugged in here. But it would be f prime of 3 if you saw a 3 here, or f prime of 5 if you saw a 5 here. So this is the derivative at 2. The derivative is 4. Well, what does the derivative mean? Well, guess what? Derivative is slope. So we have the derivative, which is 4. So that means our slope is 4. Here we have a point, which is 3, 2. Here we have a slope, which is 4. Let's make the equation of our line. That means we have y minus 2 equals 4 times x minus 3. I'm going to distribute the 4 to this parentheses here to get y minus 2 equals 4x minus 12. I'm going to add the 2 over to both sides to get y equals 4x minus 10. And to find the x-intercept, we need to find the value of x that causes this to be 0. So if I set this whole thing equal to 0, the value of x that causes this expression to be 0 is x equals 5/2.